So when we continue, now we will discuss the geometric distribution. Again, another discrete distribution, which is a special case of negative binomial distribution, where you are curious about only the first occurrence of a specific event, not the rth occurrence, but the first occurrence. It means that you override your r with 1. That's it. And your y will be the required trials until the desired event occurs. Of course, including the last trial, which is the event itself. That's the idea. When we take a look at this with, let's say, fresh board, let me check. So your probability of y equals y here, probability of y be p q y minus 1. That's it for y equals 1, 2, 3 up to. These are number of your trials. The trials until the desired event occurs. Let me write this. Okay, those are the required trials until the desired event occurs. So when you take a look at the expected value of this y, which is y, it would be 1 over p, right? In fact, this one was r before in the negative binomial distribution. Since your r is equal to 1, it is 1 over p. And your variance will be just this one. It is q over p square, which was, and you also had some r here, but since this one is equal to 1, it will reduce to this value. Now let's just solve an example here, and I hope that everything will be more clear. This is the example from our textbook. We have a test bed for light bulbs where they can be defective with the probability of 5%. Okay, now the first part of the question is the probability that the first defective bulb is within first 5 trials. The first defective bulb is within first 5 trials. Within to understand is the key here. If you're if you generalize this, like a probability of y equals the p being defective, this is what we're curious about, and point y minus 1 here, and here your y goes from 1, 2, 3, blah blah, it goes like this, and the probability of, this is what we're talking about, understanding the question within. So you set up the question like this. It means that you're curious about probability of 1 plus probability of 2 plus probability of 3 plus probability of 4 plus probability of 5 within 5 within those first 5 picks. The first error is within those 5 trials. So it would be 0.5 plus 0.5 times 0.95, okay, plus 0.5 times 0.95 square, okay, plus 0.5 times 0.95 to the power 3 plus 0.5 times 0.95 over 4. This is what we're dealing with, right? So this one is this one, 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 and this one is this one, right? Since we're bound with the formula here, and our result will be, if you make the necessary calculations with your calculator, 0.22. So it's roughly like approximately 22%, like 22% probability. There's a 22% probability that the first defective bulb will come within the first 5 trials here. And the second part of the question is about the mean and variance of the distribution. Find the mean and variance of the distribution. So what you have here will be EY. This is the expected value of mu y. It's 1 over. So you're expecting, in fact, 20 trials until the first, broken defective light bulb occurs. Okay, this is pretty interesting, right? This is mathematics or statistics, but the thing is, this is what we're expecting, okay? But you will be, since this is 20, it can be a bit, let's say, surprising, maybe. Maybe it's a bit surprising, but when you take a look at its variance, you will be, I think, convinced that the variance is crazy as well. So you can expect it at any time at all, because the shape parameter is crazy. It's this one, 380, and your standard deviation would be like crazy. It's 19 point. So now I think that makes sense. So your average is 20, and your this is your standard deviation, right? And this is your but the thing is, the author was asking about the variance, so your variance is 380, and this is all about the geometric distribution as well.